Solving rational equations. The first part of this section is a review of what we already talked about in a previous section. So let's review that quickly before going on to another idea. First of all, remember, we're solving rational equations. When we talk about rational, we're basically talking about fractions. So if you are given the equation x over 4 subtract x over 7 is equal to 3, in order to solve that, the best way to go through is to, first of all, get rid of the fractions. I'm taking a look at that and I'm saying, well, the least common denominator of 4 and 7, or the least common multiple of 4 and 7, is 28. So what I'm going to do is I'm going to multiply both sides by 28. So as I write that out, 28 times, in parentheses, x over 4 subtract x minus 7, remember that you do need to multiply both sides by 28. Then what I'm going to do is I'm going to multiply 28 by everything that's inside the set parentheses. In doing that, I am going to go through and say, well, the 28 and the 4 cancel out, leaving me a 7. But now, remember, I also need to multiply the 28 times the x over 7. So once again, the 28 and the 7 cancel out, leaving me a 4. So what I get is I get 7x subtract 4x is equal to, and then I'm going to multiply 3 times 28. 3 times 28 is equal to 84. And then I'm just going to go through and continue to solve this. 7x subtract 4x gives me 3x, so 3x is equal to 84. I'm going to divide both sides by 3. I'm going to get a final answer here of x is equal to 28. Remember, whenever you do get done with something like this, you're going to put the 28 back into x in the original equation and make sure it works. So I have 28 over 4 subtract 28 over 7, and does that equal 3? 28 divided by 4 is equal to 7. 28 divided by 7 is equal to 4. So I get 7 minus 4 is equal to 3. So yes, that does check, and that did work. Let's do one more problem before moving on to another idea. If you'd like to, you can turn this off and work this problem on your own first, and then turn it back on again and watch me. Okay, hopefully you've had a chance to go through. I'm taking a look at this and I am saying that the least common multiple of my denominators is 12. So what I'm going to do is I am going to multiply both sides by 12. So I'm going to put parentheses around both sides, multiply both sides by 12. The very first thing I'm going to do then is divide the 12 times the x over 12. The 12 and the 12 cancel, just leaving me with the x, so I have an x. I still need to multiply the 12 times the 1/6. The 12 and the 6 cancel, leaving me with a 2, so I get x minus 2 on the left-hand side. On the right-hand side, the 12 and the 12 cancel, just leaving me with 2x subtract 7. And now I'm going to go through and solve this. I'm going to get the x's by themselves. There's all sorts of different ways of doing it, but one thing I might do is subtract x from both sides first of all. On the left-hand side, I get a negative 2. On the right-hand side, I get x subtract 7. And now I want to get the x all by itself, so I am going to go through and add 7 to both sides. When I add 7 to both sides, I get x is equal to 5. This is one that, once again, I can go through if I want to and put 5 back into the original equation. Doing this, it's not going to be quite as easy to go through and solve, but let's go through and do that. I have 5/12 subtract 1/6 is equal to, if I put a 5 in for that 2x, I'm going to get 10 minus 7, which gives me a 3, so I get 3/12. So the question is 5/12 minus 1/6 the same thing as 3/12? Well, in order to go through and subtract fractions, I have to have the same denominator. So this 1/6, if I change it into twelfths, it would be 2/12. So I would have 5/12 minus 2/12. 5/12 minus 2/12 does equal 3/12. So yes, that answer 5 does check. The new idea in this section talks about how to go through and solve rational equations if you just have equivalent fractions. But let's talk about equivalent fractions for a moment. I'm just going to write down some equivalent fractions here. We know that 2/3 is the same thing as 4/6. If we multiplied 2/3 times 2/2, we would get 4/6. We also know that 4/8 is equal to 5/10. Both of those are equal to 1/2. We'll put them into lowest terms. So those are two equivalent fractions. And I could also then give you one more. We know that 3/4 is exactly the same thing as 6/8. I have all those equivalent fractions. And one thing to notice about equivalent fractions is if you go through and you multiply the numerator in one of them, let's look at this one. If this is the numerator in 2/3. If you multiply the numerator by the denominator, I'm going to get 2 times 6. If I do the same thing, the numerator times the denominator, the other pair, I get 4 times 3. And 2 times 6 is equal to 12. 4 times 3 is equal to 12. In other words, if you multiply one numerator with the opposite denominator, you're going to get exactly the same answer when you do that both times. Let's check. 4 times 10 is 40. 8 times 5 is 40. So 40 is equal to 40. In the last one I have, 3 times 8 is equal to 24, and 6 times 4 is equal to 24. Anytime at all that you have equivalent fractions, this is always going to be true. So we can use that in order to figure out what might be the missing number if you are given a fraction with a variable in it. So I have 8/10 is equal to 12 over something. If I wanted to figure out what that x is, all I need to do is go through and multiply the two that I know. I know 12 times 10 has to equal 8x. Well, 12 times 10 is equal to 120, so 120 has to equal 8x. If I divide both sides by 8, I'm going to get x is equal to 15. So 8/10 is the same thing as 12/15. Let's do another one. I know 10 over 6, I want to be equal to x over 9. What's that x going to be? Well, I'm going to go through and say, well, I know 10 times 9 has to be equal to 6x. 10 times 9 is 90. 90 is equal to 6x. Divide both sides by 6. Once again, I get x is equal to 15. It just worked out the same as the last one. I get an answer of 15. We can use this idea in order to solve more complicated rational equations. So I have 2/5 is equal to x minus 2 over 20. So I know that 2 times 20 has to equal 5 times x subtract 2. If I'm going to go through and solve that, 2 times 20 is equal to 40. I need to get rid of the parentheses on the right-hand side. I get 5x subtract 10. And then I'm going to go through, I'm going to add 10 to both sides. If I add 10 to both sides, I get 5x is equal to 50. And then if I divide both sides by 5, I get a final answer of x is equal to 10. One idea to remember. And this idea of cross multiplication only works if you have two fractions in the problem that are equal to another. I'm not going to go through and solve this problem that I'm going to show you, but if, for instance, you had 2/5 is equal to x minus 2 over 20 plus 5, you could not go through and do this because you don't have just two fractions that are equal to each other. If you were going to solve a problem like this one that I have in the green, then once again, I would have to go through and multiply both sides by the least common multiple, which in this case would be 20. So I'd be multiplying both sides by 20 as we were doing before, getting rid of the fractions and solving it that particular way. Here's another example. Once again, I have two fractions that are equal to each other. So I'm going to go through this process of cross multiplying. I'm going to go through and say, well, 5 times 21 has to equal 15 times x subtract 3. Make sure that that x subtract 3 is inside your set of parentheses. I know that 5 times 21 is equal to 105. So I have 105 is equal to 15x subtract 45. I'm going to add 45 to both sides. If I add 45 to both sides, I get 150 is equal to 15x. And then I'm going to go through and I'm going to divide both sides by 15. When I do that, I am going to then get a final answer of x is equal to 10. And once again, I would be going through and checking to make sure that that works. So I am going to have 5 over 7 is equal to 15/21. Is that true? Well, if you have 5/7 and you wanted to change it to 21, I would multiply times 3 over 3, and I would get 15 over 21. So that is a true statement. X does equal 10. Here's one more example of two fractions that are equal to each other. Once again, if you'd like to, you could turn this off, do the problem yourself, and then turn it back on again and check and see whether or not your answer matches mine. As I go through and do this particular problem, I am going to once again cross multiply. So I know that 12 times in parentheses x plus 2 has to equal 20 times in parentheses x subtract 2. I'm going to be getting rid of my fractions, or my parentheses I should say, first of all. So on the left hand side I'm going to have 12x plus 24. On the right hand side I'm going to have 20x subtract 40. I want to get the x's all by themselves. I would go through and subtract 12x from both sides. And on the left-hand side, I'm going to be left with 24. On the right-hand side, I'm going to be left with 8x subtract 40. And then I'm going to add 40 to both sides. If I add 40 to both sides, I get 64 is equal to 8x. And then I would divide both sides by 8. Doing that, I get a final answer of x is equal to 8. I will leave it to you to put it back into the original equation and verify that it does work. As always, if there's anything that I can do to help as you work through these problems, please let me know.